Hello ladies and gentlemen, my name is Omar and welcome to my YouTube channel. Today we're going to be looking at an animation rig I created for a robot with wheels. In this rig, I will be going through the facial rig setup using cops and sops, and then we will touch upon using the car RBD rig in conjunction with the KineFX tools. As always, I will be providing the rig in the description for you. However, since the robot model is bought, I will not be providing it. I hope to keep this short. Let's get going. First, we're going to be setting up the 3D model of the robot. I bought this 3D model from cgtrader.com. You can browse around and find free 3D models of robots. I added its materials. I isolated the facial geometry here, where I'm going to be adding the material texture. I added it as well. I'm going to be showing you how to create the screen here using cops in the later stage, but let's merge it together for now. And here's our Q3D model. Our idea is to feed this along with the skeleton that it came with. You see, I have the skeleton of the 3D model here. What I want to do is I want to transform them together. I have a reference copy of the transform node, which I used to rotate it 180 degrees. I used it here as well on the skeleton and I merged them together. And before I did that, of course, I grouped the wheels for RBD car rig to register the wheels. I fed this into the RBD car rig. Most of the stuff here, the parameters that you see, are left on default. I put the wheels group as wheels as I named it before. You can play around with the tire bounce, wheel wobble. After that, we're gonna create an arbitrary floor object for our robot to move through. I added a mountain after the grid node and drew a curve on top of it, as so. I used the smooth operation so that the curve isn't jaggedy, and I plugged it into the input of the RBD car follow. As you can see, the rig works as intended, and the skeleton also moves with the geometry. So everything is good so far. After that, I used an unpack operation, and I split the skeleton out. This is so that I can have controls over the KineFX rig after this. I've named some individual spheres, body, for instance, ear right, ear left, and then I have left wheel support, right wheel support. I merged them together, and I added a transparent material. I plugged this output into the input shape library input of the attached joint geo. I made sure the names of the template geometries are matching the rig joints accordingly. And if you want to see if this works properly, we can just turn the flag on for joint deform. And as you can see, our robot moves through the curve, and you have the option to animate the individual components of the rig, of the skeleton, as you can see. This is a neat trick. It allows you to bypass a lot of those complex rig additions, and you can use these in your projects. As for the facial animation, we're gonna dive into that now. I've created this HDA, but I'm gonna show you what this does properly. As you can see, I have these controls inside the HDA, which allow me to shift through different emojis, different facial expressions, while also having that pixelated look. For that, we're going to utilize sops and cops, and let's see what we're going to be creating. Okay, let's dive into our facial controls HDA. In our HDA, we have some trace nodes where I import some facial expressions. And I use the trace node to get rid of the alpha equals 0. That's why I have these expressions. I scatter some points onto these expressions, and I sort them with a spatial locality. This is so that when you switch into the next expression using a blend shape, you get the points don't jitter too much. And this is what I found to be the best option in the point sort. For instance, I want to change from the neutral face to the face which is looking left. I have the expression set on the look left portion here, as you can see, and I use a point pop. I plug in the look left expression to the second input. And inside of this, it's a very simple setup. I use a mix node here. I mix the position of the current position and the second input's position using a bias node, which I promote to the outer section. I also add a bit of a noise, and I plug it into the output of the position here. So if we slide this up, as you can see, it works. And this is also being referenced from the HDA itself. The same also works for the other expressions as well, look right in this case, and so on. Smiley face also works. You can create your own expressions. This is where the spatial locality and the point sort comes in. As you can see, you get this pixelated change when you try it like that. See? This is the gist of it, basically. You can add more expressions and you can increase the amount of sliders that you have, and you can have a variety of more facial expressions. After this, I add a color attribute to these, in this case, a white color attribute, and I transfer it onto a grid. And then I use a transform node so that I can plug this into the cops. Let's dive into the cops and see how we can create a pixelated look now. For this case, we have two elements into this. I have the lines that you see, noisy, that you would see on a noisy screen, that they're moving like this. So for this, I created a tile pattern, very simple, division size of 50, uniform jitter is 0.014, and the seed is updating on every frame, and the horizontal scale is set to 10 and the vertical scale is set to 0.14. Very simple. And I multiply this with a fractal noise, and then I remap it so that lines are visible only on certain portions, and for that to happen I push the points of the ramp all the way down. As for the pixelated look, I import the null that we created in the HDA. I rasterize the geo. I take the CD attribute, which is the color. I change the RGB into a mono. And I multiply that with a tile pattern of rectangles. The uniform jitter is set to 0.014, but the rest are default settings. And I merge the lines with the pixelated facial emotions, and this is what I have. And you can also use a mono to RGB node here at the end to give it a color. Yes, here's what we have, ladies and gentlemen. It is a simple rig. I'm going to be providing it, as I said before. You can have a robot with a screen and use the screen HDA and the CopNet to your advantage, as well as the tips that I gave you regarding using KineFX with the RBD car rig. Before we end everything else, I would like to present to you the newest version of the rig that I created. This is the file that I'm going to be linking inside the description. I have replaced the robot with a free robot, and I rigged it, and I put the screen as well with the material. You can play around with this rig. As you can see, the rig works, and you can also control the portions of the rig. As you can see, the cockpit, the wheels, and whatnot. Thank you so much for watching, and subscribe and like for future content. Thank you.